Hi, this is Mrs. Gergis, and today we're going to go over gas properties. And gas properties are amazing, but we're going to focus in on gas properties when it comes to diffusion. Now, diffusion, as you can recall, is where particles or molecules travel from a higher concentration to a lower concentration. What I want you to do here is I want you to click on the plus sign so that way we can see the data and you can discover here and play with all of these different scales and stopwatches and use all of these different variables to gauge your understanding. So what I'm going to do here is I'm going to add about 50 particles of this blue gas atom. Okay, and as you can see, I have a higher concentration here on my left vessel than I do on my right vessel. Okay, what I'm going to do now is I'm going to remove our divider. Okay, and as you can see, this lever, which determines particle flow rate, the center of mass, is actually moving straight to the right. Okay, with time, you can notice that it's going to kind of be in the center, okay, or toggle up and down along the center. And that is because the rate of diffusion has reached its equilibrium. Okay, again, you can do this and reset this experiment where you can add an equal number of particles, but this time I'm going to add a mass. I'm going to maximize my mass of these blue particles, and then I'm also going to add 30 particles, so 30 and 30 of the blue and the red. And with these red particles, I'm going to make them a little bit lighter. Okay, so the mass is going to be a lot lighter than, say, these guys. So as you can notice, you notice that over here on the right hand side, they're moving a lot quicker than, say, these heavier particles. And I'm going to include the center of mass and the particle flow rate, our scale. I don't think we need our stopwatch, but I'm going to take off I'm going to remove the divider in between these two, and you can see the rate of motion. These particles moving from left to right. And eventually they will soon reach equilibrium. You'll notice that the red ones are actually reaching closer to equilibrium at a faster rate towards the middle than, say, the blue particles. Okay, so now that we have that figured out, you can either press this little house button, or what I like to do is just click on ideal. Okay, so in this ideal chamber, you can adjust the three variables that we talked about that affect diffusion. And those three variables are temperature, so you can add heat and cold. You can add concentration, meaning add more particles at one time. And then you can even adjust the pressure by reducing the volume of the chamber. Okay, so let's add some particles, and you can do this way, or you can click on here. Okay, now what's really cool about this is you'll see that we have a higher concentration all the way to lower concentration. These particles are moving back and forth. And we can also add a collision counter. Okay, so the collision counter right now, when our temperature is at 300 Kelvin, or you can say 27 degrees Celsius, we can figure out how many times these little particles hit the wall, and it's saying about 129 collisions. Now, what we can do is we can add pressure by reducing the volume, and you can see that the pressure is going up But I'm going to add more pressure. And the way I'm going to add more pressure is to add heat. Adjust the temperature, which is another variable that affects the rate of diffusion. And you'll notice that my vessel actually blew its top. I can return the lid. What happens if I add more concentration? Up again, it caused the lid to explode out. So I want you to, make some adjustments and make some observations and discover what is happening here. Apply those three variables that affect diffusion so that way you can better develop your claim, evidence, and reasoning, your scientific argument.